Good evening and welcome to tonight's webinar, looking at the revised silverleaf whitefly management guidelines brought to you by Cotton Info, CCA, QDAF and the University of Southern Queensland. My name's Janelle Montgomery and I'm the CRDC Program Lead for Cotton Info. Helping me in the background tonight, we have Megan Woodward, who's the Cotton Info Communications Manager, and Annabelle Twine, Cotton Info's Regional Extension Officer based in the Darling Downs. We also have Liesl Coggan on the webinar here today from Crop Consultants Australia. She's the Events and Communications Manager for CCA. So thanks for your support in the webinar tonight. So the industry spoke and CRDC listened. There was a need to revisit the silverleaf whitefly sampling methodologies and the thresholds and management guidelines, and you'll be walked through these tonight. I'd like to introduce our first presenter, Dr. Paul Grundy, Principal Scientist with QDAF and the Cotton Info IPM Tech Lead. Now, Paul has worked in the fields of cotton pest management and farming systems for over 20 years, right across the cotton industry, including a lot of work in the far north. His most recent cotton research has looked at the ability for cotton to compensate with early season damage, and then in the last year he was given the task to find a more user-friendly way to monitor and manage silverleaf whitefly. So, with no further ado, I'll hand over to Paul Grundy. Thank you very much.
Thank you for joining this evening, and I'm going to share with you today the revised silverleaf whitefly sampling and threshold matrix for 2024. I'm going to take you on a little bit of a journey, give you the background of, where a lot of this work originally began, quick overview of some of the problems that have emerged, and then obviously step you through the revised sampling plan and matrix. And then I'm going to hand over to Derek Long at the end of my talk, who'll step you through a new app that he's going to talk to you about for looking at the viability of silverleaf whitefly nymphs. A little bit of background around silverleaf whitefly sampling and threshold decision making. So the process that we've used for sampling and control thresholds has undergone a number of changes since those very first outbreaks in central Queensland in the early 2000s. We initially, after a lot of work that was done by Richard Sequeira at Department of Agriculture in Emerald, ended up with a sampling plan that was based on sampling of the adult stage of this pest on the 5th node leaf. And many of you that have been around for a number of years would recall that sampling strategy. This particular strategy was based on a binomial sampling theme, in that leaves that had 2 or more adults present on that 5th node leaf were classified as infested. Leaves with no adults or only 1 adult were classed as uninfested. And essentially we calculated the percentage of infested leaves and then used a decision matrix, you might recognise that one on the right-hand side of the screen, to basically plot where the level of infestation was in your crop against those different population curves so that you could then arrive at a control decision. Now, this approach was always a compromise, because when Richard did this work originally, he found that the nymph counts, and he did a study over 3 years in central Queensland, gave a much better correlation to the population dynamics that were present in the field. But the industry feedback at the time was nymph counting was unacceptably time consuming, so we ran with the adult method for sampling whitefly. Over time, though, as whitefly spread throughout other parts of the industry and more people were using this strategy, it did become quite clear that sampling of adults was not giving us a good enough result when it came to sampling silverleaf whitefly making control decisions. So based on some of the problems that emerged with that original sampling strategy, a lot of work has since been done. It was led by Richard Sequeira again, but he teamed up with Simone Hamona and her team at CSIRO and Narrabri. And what they did over a period of several years was did a whole lot of work trying to understand silverleaf whitefly distribution within the plant, and then to link that population dynamic within the plant with the broader population dynamic of the silverleaf whitefly population across the whole field. And they did this at locations ranging from Narrabri to St George. Research confirmed that adults were highly mobile within the canopy and therefore not suitable a target for sampling. So that did confirm why adult sampling wasn't working terribly well. The nymphs, as it turned out, were a much more reliable sampling target, but not at the 5th node leaf. And what they found, looking at the dynamics of this pest within the cotton plant's canopy, it was the mid-canopy zone that provided the optimal location to sample for those nymphs and would give you a number that was representative of that field population. So we're talking about main stem leaves born from nodes 11 to 14 if you counted your way down the plant from the terminal at the top. So this work gave rise to the decision support tool, and this was released to industry about 3 seasons ago. And Richard developed this tool that was based on an extensive amount of work done to understand the population dynamics of this pest. And essentially, it allowed you to track the population that was present in your field and plot that population against 3 distinct risk pathways. And those risk pathways were associated with the risk posed by that given population to your field from the perspective of the lint being potentially contaminated by honeydew at the end of the season. Now, to use this DST technique, it required all the nymphs that were present on the leaves to be counted, and then those nymph counts needed to be entered into a spreadsheet to convert the data into a log 10 scale. And the reason for this particular scale is it gave a good fit for those complete nymph counts, and it took into account that variability that you might get from leaf to leaf, where you might have several leaves with a 0, one leaf with 10 nymphs, another leaf with 2 nymphs. The log 10 scale worked quite well at smoothing that out. The nymphs also needed to be categorised with this tool into nymphs that were viable and those that were unviable due to either parasitism or the effects of insecticide. Feedback, however, I guess since the DST was released from users, indicated that nymph sampling and the office-based side of data handling with having to count information into a spreadsheet to convert it to a log scale was time-consuming for a lot of users. Also, the classification of nymphs into either viable or non-viable was an additional difficulty for some users, and it really did depend on the experience of the individual doing those assessments as to how accurate they would be. In lieu of these problems, I commenced some work together with the University of Southern Queensland, where we looked at how we might be able to ease the burden of having to count all of those nymphs on all of those leaves. And we developed a product called the Pest Detect app, which aimed to overcome that constraint by using smartphone photogrammy to image those leaves, and then from the image analysis and an algorithm, essentially count the nymphs that were present and populate the DST, so saving that particular job from the user. This app was released last year, but the performance of the app was below our expectations. And the reason for that is that we found that when we got it into the hands of a lot of different users, that there was much more variability in the way images were taken for scanning, differences between the way images are captured with different phones, and the app also did have some functionality issues. And as we reviewed that at the end of last season and looked at potential solutions to those problems, we did come to the conclusion that taking hundreds of images week in, week out to inform the DST was probably something that was out of scope for a range of different consultants. So how could these challenges be overcome? The research that Richard and his team did certainly confirmed that the presence of nymphs on the leaves sampled from the mid-canopy was the best indicator of silverleaf whitefly activity and the population trajectory that's present in your field. A key question that I started to ask, though, was could the sampling be simplified to avoid the need for that log 10 transformation of the data? What I started to do was look at some of the comparisons between the curves that Richard had come up for the DST and curves that he'd originally developed for the adult curves. And what struck me fairly quickly was that the pathway for the adult curves from the original threshold and the DST pathway, particularly around the moderate risk curve, fitted fairly neatly and had a similar pathway. And it's not surprising when you stop to think about it, because what we're talking about, or what these models are modelling, is the expected rate of increase for a silverleaf whitefly population in the paddock. So it's not that surprising that the population measured as adults, as opposed to the population measured as nymphs, would have a similar trajectory, given that it's all part of the same population. So I had a bit of a look and started using some of the existing field sets of data that we had that were collected around the Goondiwindi area, and started playing around with those data sets. So it was sample data from the field collected week in, week out over the course of a season. And I compared a number of different ways in which that sample data could have been collected. So I graded all of those leaf counts and went, okay, let's have a look at those leaves and count them as positive leaves or negative leaves if there was 1 nymph per leaf present, or 2 nymphs per leaf present, or 3 or 4. You get the general gist of what I sort of went through the data and did. And what fell out fairly quickly was that if we looked at that leaf sampling data, which was quite detailed, and graded those leaves into infested leaves and non-infested leaves, with infested being 2 or more nymphs, and plotted those against those original adult silverleaf whitefly curves, we ended up with a very similar output to what you would achieve with the DST using that same nymph count data, where you entered all those nymph numbers and then did the log 10 conversion of that data. I discussed this with Richard and tried to identify where the flaws might be with this process, and looking at 23 fields of information where we had very, very detailed counts, and did side-by-side comparisons with this technique compared to Richard's DST. And we found that over those 23 fields, which spanned a number of seasons and a number of locations, that on each and every occasion, both methods essentially gave the user the same outcome in terms of where that population tracked in relation to those curves and would allow you to arrive at the same control decision. So consequently, based on this, I've used this approach to revise our methodology around sampling silverleaf whitefly, and have arrived at a 2024 recommendation for both sampling and your revised decision matrix. So if I start with the revised sampling plan is based on the presence of nymph on the leaf undersides. We know from the work that's been done now, both originally in central Queensland and then comprehensively in southern Queensland and northern New South Wales, that nymphs in the mid-canopy are going to give us the most accurate idea of how that population is tracking across the field. Ideally, we want to commence sampling around mid-flowering, so for many crops that would have been about a fortnight ago, with main stem leaves taken from the mid-canopy. And what we mean by the mid-canopy is, if you count down from the terminal, about 11 to 14 nodes, that's the zone where we're sampling those main stem leaves. And essentially now, rather than counting all of the nymphs on those leaves, as you would have to do with the DST, we're now just going to count or look for the presence of large nymphs. When we have 2 nymphs or more on that leaf, it's just counted as being positive. If there was only 1 or no nymphs on that leaf, it is negative, and then you move on to the next leaf. The number of leaves that you would sample in the recommendations remains unchanged. However, instead of calculating a log 10 scale, which required you to go back to the office and enter the data into a spreadsheet, you can simply calculate the percent of infested leaves that you've sampled in the field and refer to the revised decision matrix. So the revised decision matrix is a bit of a blend. The curves that are present on this model are more or less the same as those original adult silverleaf whitefly curves. They just happen to work very well for nymphs with this binomial sampling strategy. And you'll see, though, that we've separated those zones into zones that are exactly reflective of the DST. So we have a high-risk zone, a moderate risk zone, and a low-risk zone. And keeping in mind that those risk zones are basically related to the probability that you may have a problem with honeydew contaminating lint later on in the season during the open cotton stage. You'll see that day degrees on this model has been expressed and calculated using the 1532 day degree model. Given that the base 12 model is slowly being phased out and is unlikely to be supported in the next couple of seasons as the industry transitions to the 1532 model, we thought if we're going to revise this, we might as well just start with the 1532 day degree model. You'll see that within those curves, we're avoiding treatment prior to 800 day degrees, which is about mid-flowering, irrespective of whether that population is tracking in the high risk or moderate risk zone. And the reason for this is that populations at this early stage in the season is too far out for open cotton for those populations to pose a risk with honeydew to treat at this early stage, unless you, of course, were using a product for another pest that did offer some suppression, would really be targeting a population too soon, and there would be a good chance that population would re-establish and would need to be treated again prior to the open cotton stage. So our zone for control, and again, similar to the DST and also borrows a bit from that original version, is in that zone between 800 day degrees, which is about mid-flowering, through to about 1050 day degrees, which is first open bulb. If you're in the high risk zone and you had 2 or more consecutive checks that were in that zone, it's an unambiguous need for control. So that is a high population of whitefly. Populations tracking in that period in the moderate zone for 2 to 3 checks, again, similarly represent a population that is in need of control. Whereas populations in the low risk zone during that time period are really unlikely to pose a risk for lint contamination. What we've done to go hand in hand with this is we've also come up with a more concise and to the point set of advice around what you might do in each of those zones. So we've got the low risk, moderate risk and high risk zone. We've got an open cotton zone and an early season zone. And I've aimed to put the advice, and it's not new advice, it's basically taking the advice that's always been there, but put it as succinctly as I thought could be possibly done, so that it's just very clear what the considerations are at each one of those points within that decision matrix. What are the factors that you might need to consider, and what are the things that you take into account when arriving at a control decision. So again, we'll put some links up that refer to where you might find this information after this webinar. The thing that's a little bit different to the DST, and again, this detail was on the DST, but probably not as prominently on this revised risk model. And really, at the end of the day, our management of this pest is all about preventing honeydew contamination of cotton lint, is we now have an unambiguous open cotton section. The reason why we've changed that around and why you wouldn't continue to track those high populations through that open cotton stage in terms of whether it's a moderate risk or a high risk is that your management of silverleaf whitefly, once you have open cotton, needs to be about more than just the population dynamics in that field in the sense of a given number of whitefly on a set number of leaves. It needs to also take into account the viability of those nymphs, the presence of honeydew in the lower canopy, weather conditions, seasonal conditions, how long have you got to go to defoliation, what mode of action of the products that are available to you that you might consider using, and also what risks are there of population resurgence or adults migrating from another field that might be defoliated from an earlier sown crop. So there's a whole lot of factors that come into open cotton. I kind of felt that it was disingenuous to start splitting high risk and low risk during that stage. And basically we've come up with a design where we're basically saying there's a low risk population that really shouldn't pose a huge risk for sticky cotton, but basically anything above that does pose a risk if it remains. But whether or not you would treat depends on a whole range of intersecting factors. With the DST, we were asking people to assess nymph viability throughout the life of the crop. Looking again at the field data of a comprehensive number of fields, what we found and what kind of fell out, and this does fit with lived experience, is that mortality really does start to pick up from a bit after cutout through to first open boll. And that's because parasitism tends to increase at that time. It's not to say that parasitism isn't important before that, but we start to see noticeable levels of parasitism. And by that, I mean you start seeing parasitism at 10, 20, 30, 40% in that zone, whereas earlier on the levels are quite low as those populations are ramping up. So we thought it was prudent to put that effort in assessing nymph viability where it really matters, and that's in that open cotton stage where you're going to use that information to balance your control decisions. Also, if you've used an IGR or another product during that previous sort of phase in life of the crop, it's during that open cotton stage that you might have a lot of nymphs present, but on closer inspection, those nymphs may already be on their way out from mortality from insecticides or in fact dead nymphs already. The other sort of point that's worth making for this particular zone is the low risk zone is not a no risk zone. So there is still a risk of lint contamination for populations tracking in that low risk zone, but it is a low risk. And really the factors that might make it a low risk as opposed to a no risk is things such as if February and March are extremely dry, which we did have back in 2017-18, and a few people had problems with stickiness with a population of whitefly that they'd always managed previously, and then it was problematic in that year, and it was because it was incredibly dry. So it is a low risk, not a no risk, and you just need to be mindful that if we have a really dry finish to the crop, that can exacerbate a small amount of honeydew. Alternatively, you might have a delay or an anticipated delay to defoliation. That might change that risk. So we're not saying ignore whitefly during that stage, we're just saying it's a low risk. So just before I finish up and hand over to Derek, just a few other things I thought to keep in mind. So this really has just been focused on a new sampling strategy or a revised sampling strategy and a revised matrix. But look, insect management at the end of the day, it's dynamic, and our job as managers is to collect the best information we can and combine it with our experience. So in terms of thresholds, they're not perfect, right? They're created by people such as myself, people like Richard Sequeira and others, Lewis Wilson. There's been a lot of people working on a lot of thresholds for our pests, and these thresholds are created from purposely collected data with the best of intentions, but they always come with some limitations. And this is why pest densities, which is what our thresholds tend to be focused on, it's X amount per metre or X% of leaves or whatever it might be, is a central factor, but it's never the only factor for decision making. The information that accompanies the matrix that I've sort of revised and put together, I'm hoping will provide you with a range of prompts for the factors that you'll need to consider when making control decisions. Insecticide efficacy is also a really important point to consider, and what product you choose, when you choose to use it, and where will have a big bearing on its performance. And often when people report poor performance from a product, and we've gone in and taken samples for resistance testing by Jamie Hopkinson, and we've found that those products are still very effective. But sometimes there's a circumstance where you might have a population that has gone a little bit too high, and in effect, we're asking a bit too much of some of the products that we have available to us. So again, the matrix has good information about the types of products and when you might use them in relation to those population trajectories and the time of season that we're in. Finally, there's resistance, and it's something that we need to keep in mind. Pyriproxyfen is an excellent product choice and remains so for mid-season. We're asking industry, and have done now, so this is certainly something that nearly everyone would be familiar with, that you limit your use to one application per season, and there's a prescribed window that's agreed upon for each valley throughout the industry. There's low levels of resistance to this product, but those resistance levels have remained stable, and I think that's testament to the changes that we've made around the stewardship of that product. Spirotetramat is another product. It's an excellent choice, particularly where crops have large closed canopies, and that systemic activity really is advantageous in that scenario compared to some of our other products that are a little bit more coverage dependent. It's important to realise there is low levels of resistance across all valleys to this particular product. The form of resistance that Jamie Hogginson's detected is highly dominant, and once populations do become resistant, it's a form of resistance that is unlikely to be readily reversed. So for that reason, again, Spirotetramat is limited to one application per season. Silverleaf whitefly do remain fully susceptible to diphenthyrone, which is Pegasus. However, you need to be mindful that when we are thinking about resistance management, we need to think about more than just the pest we're targeting. And last season, Lisa Bird picked up resistance to diphenthyrone in northern New South Wales at a range of locations. And that's a troubling development, because if you look at the number of active ingredients available for the effective management of two-spotted mites, there's not too many products on the table, and diphenthyrone has been an effective product. So we really don't want to lose diphenthyrone. I think that limits us down to about 2 modes of action for which we don't have resistance, which is not really where we want to be. So we want to maintain as many modes of action as we can. So again, keep in mind, diphenthyrone now is one application per season, not from a silverleaf whitefly perspective necessarily, although it's good practice for that, but more from the perspective that mites are usually always present in these fields as well and would be selected for with resistance. So I'll conclude there, Annabelle and Janelle, and hand back to you.
Thanks very much, Paul. You've done a lot of detailed research there, taking into account the work that Richard Secura had done previously for the DST, and that's also led to, moving through into our new revised techniques. So thanks for stepping everyone through that tonight. In terms of looking at our nymph viability, we have Derek Long to talk to us about the silverleaf whitefly nymph app. So I would like to introduce Derek Long, the Research Engineer and Lecturer at the University of Southern Queensland. Derek's research specialises in image analysis for agricultural applications with a range of platforms, including drones, tractors and smartphones. His current research has investigated the potential for smartphone sensing for crop scouting on farm. So thanks very much, Derek.
Thank you. Good evening, everyone. I'll start with screen sharing from my phone into the webinar so that I can take you around the new app that we're calling NymphCheck. This is a refinement from the Pest Detect app and is really focusing on the mode that uses the microscope lens attachment to analyse just 1 or 2 nymphs per photo to tell whether they're viable or not. It'll take me just a few minutes to go through that, and then I've got some slides as well. So got the Pest Detect there on the left and the tentative icon for the NymphCheck app on the right. For those familiar with the Pest Detect app from last season, the simplified version here is removing, say, farm and field structure and just giving us a really easy portal to either play around with just single photos or group them into one sample. So having a single field sample that would let you take a set of 10 or 20 photos and have some summary statistics of those, and then you can dump them, move on, and it's much easier to use. There's mainly just 3 buttons on the screen there. There's a bit of other information on the side menu, but really what we're looking at is some user guide information on the top button. So I've just clicked the top button. It'll take you to the lens, some purchase links if you need more, FAQ and what the photos should be looking like. For the middle button, playing around with single photos, we can still take them out of the phone library if you already have them. We can take one from the camera right then and there, or there are some examples that are preloaded onto that. So this is what the whitefly look like when we've got the particular microscope lens attachment that we're using with this app. So there's just a couple on there. And lastly, the sample. It holds 1 in memory, and I'm going to discard it now just to show loading in a bunch of photos I've got on the phone. I'm just going to grab 10 or so there. These menus, again, might be familiar to people who use the Pest Detect app, and we still have the ability to inspect these. So I can click on one here and take a closer look at one that it's identified 3 that are not viable. It processes a bit faster too, so it's a bit lighter on battery than the Pest Detect app. The processing required to look at these particular photos is a bit less, which is handy for us. And we can also get some summary statistics here. I've got a little button on the bottom right called results, saying that we've got about 50-50 split between the 12 photos that I've loaded on. We've also maintained the ability to use the camera in a loop. So take photo would do one and multiple photos would do a bunch. It's a small, simple app. It's taking out the components that we felt did land well with the Pest Detect app and making them a lot easier to use. And they're also the most relevant elements of the app with the revised sampling protocol. I'll give a little bit more information now about how the app is going to roll out and what accessing it is going to look like. The NymphCheck app is going to go into closed beta for the current season, so it's not going to be a publicly accessible app. We're just going to be moving a bit slower with this one and a bit more cautiously so that we can get it right the first time. The lens that we need to use with it will be supplied for you, so we've got a bunch of those lenses ready. Getting access, as indicated in the newsletter and communications that have gone out, you need to reach out to the project team directly to get access. We will be in communication with you around getting some links and sending a lens out if you don't already have one. There is an expectation for those who do use it that you'll engage in that. We want to know what is and isn't working so that we can iterate and really land this one well. And we aren't taking the Pest Detect app offline this season, so it's still going to be on the App Store this season for people who want to use that as well, or using some of the other functionality in that as well. So we're going to have both apps online in a way for this season, and then we're going to assess from there. There's a couple of different things to note for people depending on your platform. So some people will need to install it from a downloaded file. For iOS users, there's a test flight app that you'll need to download and use. And we'll be able to manage updates through that as well. So again, for people who reach out to us to get their hands on this, we'll take you through that. Our expectations are that there are going to be updates throughout the season. So what will be shipped at the start of February, we're calling version 1.1. And it's the app that I've just run through, which is mostly the lens mode from last year, but it is easier to use and more accurate as well. We have brought the accuracy numbers up, iterating year on year. We're planning to put an update to that out in early to mid-March, and there's going to be general benefit, again, of further improvement to the general use, but it's targeted specifically at not only having the image analysis working quite well for the example image on the right, but also for the more cluttered images, one of which we saw in an earlier slide. So I've got a little bit to do to have it good for those high density images as well. And so we'll have that pushed out before you start seeing that in the field. It's not just going to be that. I hope we only need to push out one update throughout the season, but we are going to be active on this if we need to do more. So ongoing support will be there as needed, and we'll be also circulating a survey towards the end of the season. That was as much as I really wanted to show you today. We're quite happy as a team with how the revisions have landed, and we acknowledge that it's an ongoing battle to nail these sampling practices just right. But with the new decision support and the new app, we think we've got a really good step forward this year. Thanks very much.
Thanks very much, Derek. I just have one question, just to be clear. If we are wanting to use this Nymph app, I'm assuming we only really need to use it once we've got open bowls.
Yeah, look, Janelle, good question. So you can use the NymphCheck app anytime, really, that you've got nymphs in the field. But what we're suggesting is it is an extra job to do. It does take a little bit of effort. And what we found when we reviewed the field data is that mortality within the nymph population really starts to pick up from after cutout. So as we come into first open bowl. So we're suggesting that people put that bit of extra effort in with their sampling using the NymphCheck app, or they can look at those nymphs with magnification if they've already got a microscope or some other method of doing that, but that you would put the effort into assessing the viability of those nymphs from about first open bowl onwards, because that's pretty much when you're going to see parasitism really ramping up, mortality from insecticides that have been sprayed, and that might basically take a population that might appear high, and when you do that viability check, the population might actually only be half of what it first presents as. So we're suggesting people put their effort into that period of the crops stage.
Thanks, Paul.
Derek, does it matter the version of the iPhone that you've got? Does some of your older iPhones still work with this app?
Good question. I'm thinking mostly about the camera when I'm thinking about what iPhones would work well with this. For a long time, they've been using the same or a very similar sensor, looking even back to iPhone 11 and 10, or even maybe a little bit earlier. We certainly did testing with the Pest Detect app on as early as an iPhone 7, but I wouldn't expect any of those to still be kicking around. I would recommend an iPhone probably within 3 years. I would expect within 5 will be quite fine, but within 3 years would be ideal. So a 12 or upwards, I would recommend.
Thank you. And another question, Paul, are we looking at other insects to be able to adapt this app to?
It's probably a question for Derek, but look, at this stage, the app is specific to silverleaf whitefly nymphs. The training data, for want of a better description, Derek might have a better description than I do, that went into it was obviously focused on silverleaf whitefly nymphs and been able to tell the difference between a viable nymph or a healthy nymph, a parasitized nymph, or a nymph that's suffered mortality due to insecticide or some other cause. So it certainly won't work on aphids, it won't work on anything else, just given I guess you just imagine the complexity of getting something to be able to tell the difference between a healthy nymph and an unhealthy one.
I'll add on if I can. At the moment, we are really focused on getting the whitefly aspect right as an initial use case. We have kind of been open about the optimism, but I think this year is going to be a great step forward for that. And I'm looking forward to seeing how the app goes in other people's hands. And the project team is certainly interested in that, but we need to get it working first well on whitefly. And when that's achieved, things can be quite expandable from there, but it starts with getting it right the first go. So I think the prospects are exciting, but let's talk after this season.
So we'd love to see some users, remembering that your feedback will be really important to Derek and his team to move forward with the app. I hope that this has been a really useful webinar for you. Up here, we've got some further information. The actual fact sheet, the 2024 silverleaf whitefly sampling and thresholds, that's available on the Cotton Info website, and that goes through everything that Paul has stepped through here tonight. There's also been 2 e-news that have been published through Cotton Info in the last 2 weeks looking at silverleaf whitefly. And if you look back on our Cotton Info YouTube channel, there's also a couple of videos there that you may like to have a look at. Jamie Hopkinson has done a great job in identifying the parasitism in silverleaf whitefly, showing us how that's done. And there's also some good fact sheets on that too. We'd really appreciate your feedback on how the webinar's gone this evening. It's really important for us to share this feedback back with CRDC. So take a few minutes of your time just to fill out a few questions. So if you can do that for us. I'd like to thank our presenters, Paul Grundy and Derek Long, very much for their time tonight and for their commitment to the cotton industry through their important research. It's great to have them share their knowledge and experience with the industry. And thank you to all of our attendees tonight for jumping on and participating in the Cotton Info webinar. So thank you, everyone, and good night.